Hello, welcome back. My name is Engineer Bismarck. You can call me Engineer. Today we want to look at integrated circuits. So as you can see here, so in short you normally hear IC. So that's it that you see here. So how do you define an IC? So you can say an IC is a small electronic chip that contains many electronic components such as transistors, resistors, capacitors, and diodes. Okay, so these are fabricated into a single semiconductor material, usually as silicon. So instead of using many separate components, just like I mentioned, an IC combines them all into one compact unit to perform a specific function. Okay, so for this IC, you can use it for signal amplification. You can also use it for switching or maybe logic operations. You can use it for timing and also control. So this is how the IC looks like. So usually when you see them on a PCB board, this is how they look like. Okay, so you can see they are very small. Okay, and it has a lot of advantages. Now when you look at an IC, you can see we have the monolithic circuit, then also have the hybrid type. Okay, so under monolithic we have the bipolar and also the unipolar. Okay, so for the bipolar we have the p-n junction isolation. They also have the dielectric isolation as well here. So when you look at the monolithic IC, this is how it looks like, and then for the hybrid or the multi-chip IC too, this is how it looks like. So when you see them on the PCB board, I'm sure you can easily identify them. Now let's see some of the classification. So we have the linear or analog ICs. Then we also have a digital IC as well. So these are some of the examples. So for analog ICs, you can see some of the examples here: op-amp, power amplifier, multiplier, comparator, voltage regulator. Then for the digital ones, you see logic gate, flip-flop, counter, then calculator, chips, memory, and then microprocessor. So now you can see the difference here. So when you have the IC, how do you determine the pins? Okay, so when you look here, this is an op-amp. Okay, that's UA741. So this is how it looks like. How do you determine your pins? Okay, so always when you have an IC, you look at the surface. You either see a dot here or you see this U shape here. Okay, so just like you see here, so the dot is usually here, or you see a U shape. So in the case where you don't see the dot and then you see the U shape, or in the case where you also see a dot and you don't see a U shape, you know that you are starting your pin 1 from your left side. So it moves in the U shape like this. Okay, so we have pin 1, pin 2, pin 3, pin 4. Then you come and start pin 5, just opposite to what? 4. You don't come and start it from the top here. Otherwise, you are going to make a mistake with the terminals and you can easily cause a short circuit. Okay, so 4, then 5, 6, then it goes up like that. Okay, so you should be able to identify the terminals, especially when you come to the lab and then I ask you, how do you find your pin 1 or how to determine the pins of an IC? You should be able to tell me. Okay, yeah, so these are examples of an IC on a certain PCB board. Now we also have some IC packages. Okay, so these are through hole ICs. Okay, so when you are working on your project. So you should know the type of packages you can get for your circuits. Okay, we also have the surface mount packages. So this is how it looks like. Okay, so these ones are not through hole type. So this one you just solder them on the surface of the board. Okay, so I I'm very confident that when you see them on the PCB board, you can easily identify them. So if it's a surface mount, you can see that, okay, this is a surface mount. So these are the flat ICs that you see on the board. So usually it's soldered on the PCB board on the surface. It's not like this one that you see that it has some pins where you have to drill a hole on the PCB board before you can what solder, which is this type. So you can see here. So you now know the difference. Okay.